Galaxies are huge objects in space consisting of billions of stars. But have you ever imagined what would happen if two galaxies collided? You don't have to imagine, because our dear Milky Way, hosting our solar system, will collide with its neighbor, the Andromeda. When does this happen? What will be the fate of the billions of stars in both galaxies? And more importantly, what will happen to you when the collision occurs? Join us in this video as we explore the Andromeda and Milky Way collision that has already begun. To understand what the cataclysmic event of two galaxies colliding means, it's essential first to comprehend galaxies, how they work and interact with one another. Galaxies are sprawling systems of dust, gas, dark matter, and contain anywhere from 1 million to 1 trillion stars that are held together by gravity. Most large galaxies have supermassive black holes at their centers, including our own galaxy, the Milky Way. As impressive as it is, the Sun is just one of about 100 to 400 billion stars that spin around Sagittarius A star, a supermassive black hole at the center of the Milky Way. This black hole contains as much mass as 4 million suns. The deeper you look into the cosmos, the more galaxies you see. In fact, one study estimated that the observable universe contains 2 trillion, or 2 million times 1 million galaxies. And that is talking about the observable universe alone. Galaxies come in different forms, and some of these remote systems are similar to our own Milky Way galaxies, while others are quite different. Astronomer Edwin Hubble, whose name one of the most popular space telescopes bear, devised a method to classify galaxies, grouping them into 4 main types: spiral galaxies, lenticular galaxies, elliptical galaxies, and irregular galaxies. Before Hubble's work, we didn't even know other galaxies existed apart from the Milky Way. They were erroneously labeled nebulae. More than 2/3 of all observed galaxies are spiral galaxies. A spiral galaxy has a flat, spinning disk with a central bulge surrounded by spiral arms. That spinning motion at speeds of hundreds of kilometers a second may cause matter in the disk to take on a distinctive spiral shape, like a cosmic pinwheel. Elliptical galaxies are generally round, but can stretch longer along one axis than along the other, so much so they begin to look like a cigar. The universe's largest known galaxies, which happen to be giant elliptical galaxies, can contain up to 1 trillion stars and span 2 million light-years across. Elliptical galaxies may also be small, in which case they are called dwarf elliptical galaxies. Elliptical galaxies contain many older stars, but little dust and other interstellar matter. Their stars orbit the galactic center like those in the disks of spiral galaxies, but they do so in more random directions. Few new stars are known to form in elliptical galaxies. They are common in galaxy clusters. Lenticular galaxies, such as the iconic Sombrero Galaxy, are a cross between elliptical and spiral galaxies. They're called lenticular because they resemble lenses. Like spiral galaxies, they have a thin rotating disk of stars and a central bulge, but they don't have spiral arms. Like elliptical galaxies, they have little dust and interstellar matter, and they seem to form more often in densely populated regions of space. You can have galaxies that are not spiral, lenticular, or elliptical. These are called irregular galaxies. Irregular galaxies, like the large and small Magellanic Clouds that flank our Milky Way, appear misshapen and lack a distinct form, often because they're within the gravitational influence of other galaxies close by. They are full of gas and dust, which makes them great nurseries for forming new stars. However, it seems all galaxies are fated to become elliptical because elliptical galaxies contain older stars and less gas than spiral galaxies. As spiral galaxies age, they lose their familiar shapes and become elliptical. But astronomers are still studying the specifics, such as why elliptical galaxies follow certain brightness, size, and chemical composition patterns. Where did galaxies come from? From the Big Bang. The universe's first stars ignited some 118 million years after this explosive moment 13.8 billion years ago. But gravity had sculpted the first galaxies into shape by the time the universe turned 400 million years old, or less than 3% of its current age. There are still open questions about how galaxies form.
Globular clusters are among the most ancient bound stellar systems in the universe.
Some believe that galaxies formed from small clusters of about 1 million stars known as globular clusters, while others hold that galaxies formed first and later birthed globular clusters. It's also tricky to figure out how many of a given galaxy's stars formed in situ from its own gas versus forming in another galaxy and joining the party later. This is one of the secrets that the new James Webb Space Telescope will unveil once it becomes operational. With its powerful lens, it will let scientists peer into the universe's earliest moments. Can galaxies collide or otherwise interact? Yes, while you will find some lonely galaxies or pairs, most are usually parts of larger associations known as groups, clusters, and superclusters. Our Milky Way, for instance, is in the Local Group, a galaxy group about 10 million light-years across that also includes the Andromeda Galaxy and its satellites. The Local Group and its neighboring galaxy cluster, the Virgo cluster, both lie within the larger Virgo supercluster, a concentration of galaxies stretching about 100 million light-years across. Galaxies and clusters often interact and even merge together in a dynamic cosmic dance of interacting gravity. When two galaxies collide and intermingle, gases can flow towards the galactic center, which can trigger phenomena like rapid star formation. Guess what? Whether you like it or not, our Milky Way is on a collision course with its neighbor, the Andromeda. It is inevitable. Currently, Andromeda and the Milky Way are about 2.5 million light-years apart, but fueled by gravity, the two galaxies are hurtling toward one another at 402,000 kilometers per hour. How did scientists work out that the two neighboring galaxies are destined to collide? It has been clear from measurements of the Doppler shift of its spectral lines that Andromeda was approaching, but such measurements can only tell you about the motion directly towards or away from the observer. Working out if we were in for a direct hit or a near miss therefore required careful study of the motion of Andromeda's satellite galaxies, and they reveal Andromeda's trajectory makes collision inevitable. When that event occurs, what happens? First, let us compare the two galaxies. The Milky Way is about 100,000 light-years across, dwarfed by Andromeda that is 220,000 light-years across in width. When it comes to the number of stars, Andromeda wipes the floor with about 1 trillion compared to the mere 100 billion in our galaxy. However, our galaxy has been around longer, having witnessed our planet going around the Sun more than 13 billion times. Andromeda is only 10 billion years old. Both galaxies are of the spiral kind. A collision between the two is not exactly a match of equals, although more recent findings put both galaxies closer in size. The interesting thing is this won't be the first collision for the two galaxies. Scientists have mapped the Andromeda and found remnants of other galaxies floating inside it. Will these billions of stars collide? The answer is a resounding no. When you look up at night, stars may look placed close together, but that is not the case. The stars in both galaxies are sufficiently far apart that it's highly improbable that any of them will individually collide. For example, the nearest star to the Sun is Proxima Centauri, which is about 4.2 light-years away. If the Sun were a ping-pong ball, Proxima Centauri would be at P about 618 miles away. Also, although stars are more common near the centers of each galaxy, the average distance separating them is still 100 billion miles. That is like placing one ping-pong ball every 2 miles. Thus, it's implausible that any two stars from the merging galaxy would collide. But then, some stars might be ejected. Remember, both the Milky Way and Andromeda galaxies have supermassive black holes at their centers. What happens to them? Well, these black holes will eventually spiral into one another and converge near the center of the newly formed galaxy over a period that may take millions of years. When the supermassive black holes come within 1 light-year of another, they will begin to strongly emit gravitational waves that will radiate further orbital energy until they merge ultimately. Gas taken up by the combined black holes could create an active galactic nucleus. If this happens, it will release an incredible amount of energy. Since our solar system is within the Milky Way, you have a right to be concerned about what will happen to it. Based on current calculations, scientists predict a 50% chance that in a merged galaxy, the solar system will be swept out 3 times farther from the galactic core than its current position, netting us a new galactic postcode. Our galaxy is organized into spiral arms, and the Sun is in a branch called the Orion Spur. If we were to be flung farther out, that means our solar system would land just at the fingertips of this arm. Scientists also predict sometime during the collision, there is a 12% chance that the solar system could be entirely ejected from the newly formed galaxy. Let's bring it closer to home. What happens to planet Earth, where we all hang out? Humanity would not be affected by this galactic collision. Before you say yippee, that is because humanity would be gone by then. Tough, right? While the collision would have no adverse effect on the solar system and the chances of any disturbance to the sun or planets themselves may be remote, we would not be around to witness it. The collision is slated for about 4.5 billion years from now, and by then, the sun would have grown from the benevolent source of heat it is now to a merciless, scorching fireball. This is because it is passing through the throes of the end of its own life and is past caring what happens to us. The increasing luminosity of the sun would have made the surface of the Earth far too hot for liquid water to exist, ending all terrestrial life. But our planet will still be caught in the middle of this collision, and its view of the universe will never be the same. Suppose we could find a way to survive the death of the sun, and we gaze into the night sky still. In that case, we will see Andromeda growing more prominent in the sky. Eventually, about 4 billion years from now, it could stretch from horizon to horizon like a serene rainbow of dew. Let's hear what you think of the Milky Way and Andromeda galaxies colliding in the comment section below.